Hello students, let's start with the next chapter of our syllabus, that is nothing but thermodynamics. So what exactly thermodynamics is, that we have to see. So first of all, let's see here, this is the word thermo and this is the dynamics. These two words together make a single word, thermodynamics. And what is the aim of this chapter, that can be understood by in this heading. Thermo is a word used for temperature, change in temperature or change in thermometer, the change in temperature, that is thermo means change in temperature. Dynamics, this change in temperature, how it affect the processes, that was studied in dynamics. So this thermodynamics is a branch of physics which deals with a change in temperature and how it affects change in temperature on different systems and what are the parameters that get affected, that we have to learn under this chapter, and that is nothing but a thermodynamics. Due to change in temperature, what are the changes occurred in the processes, that we have to see. Before going into detail, just review this 11 chapter syllabus. If you remember, in 11th standard we have the chapter thermal expansion. In that case, little bit we have learned about how the temperature changes, how the dimension of material get changed, that we have learned there. There is a change in dimension in the sense of change in length, change in volume, change in area. That part already we have learned, so that they have just tried to revise it here. Now here they have mentioned one of the best example for this. When some engines start working, at that initially when engine is in off condition, at that time the temperature of engine is low. Okay, it is equal to room temperature. But when we start the engine, after some time you can see that just if you move your hand near close to the engine, you can see the warmness, or the we can see feel the heat emitted by the engine. That means what occur, the heat get produced in the engine. Same thing they have explained by this another example. In suppose winter season, we are going for exercise. Initially when we wake up in winter season, we feel lot of cold. But when we start doing exercise, automatically start doing exercise in terms of warm up, our body temperature increases. So that is one of the example they have given. And from these two examples, what they try to explain you that here there is some relation between work and heat. And that type of thing, phenomenon, we have to learn in this chapter, thermodynamics. So these are the basic examples they have just mentioned here. And they have mentioned the something is a heat. According to modern theory, heat is a form of energy. Whenever we do the work, heat get produced, and that heat is nothing but one of the form of energy. Apart from this, another example they have taken in 1978. There is one scientist whose name is Benjamin Thompson. He observed that when the cannon was made at that time, the cannon was made from the brass block they will take, and they will drill that to make a cannon. At that time, while drilling that brass block, so they will use some drill. While drilling, it is seen that the temperature get increasing, in a large amount of temperature get increased, and it was also noticed that more heat was produced when the drill bore for longer time. If longer time we drill the bore, more heat get produced. Common sense. So if you remember, suppose we have the hexa blade, and suppose this is an iron rod, we're going to cut it by hexa blade like this. You can see just after some, just do it 2 to 3 times and just remove the hexa and touch it here. You can feel the warmness. Warmness means what? Heat get produced. So there is work when we are moving hexa up and down. This is a work, and that work get converted into heat. So that is the phenomenon that they try to explain here in terms of cannon, in terms of exercise, as they have mentioned, in terms of engine of the vehicle also. So here the work done by the system is converted into heat. So in short, this work done is converted into heat. Similarly, some people say work done may be converted into heat. So opposite of that. So same thing it occurred. Now they have given a definition of thermodynamics. Is a branch of physics that deal with the concept of heat and temperature. Thermodynamics is a branch of physics that deal with heat and temperature and their interconversion of heat and other form of energy. In short, heat and temperature, their interconversion in the form of energy. So in whole thing, there is what? Heat, temperature means what? Basic thing is temperature. That's why it is said to be thermodynamics. That branch is here. Now here in this thermodynamics, in this chapter, we are going to learn different parameters of thermodynamics and equilibrium states and the heat, internal energy, work done, zeroth law of thermodynamics, first law of thermodynamics, that we have to learn. So let's start with the first topic of this, thermal equilibrium. So let's see what is meant by thermal equilibrium. As its name suggests that it is equilibrium. It's very simple to understand. So let's start thermal equilibrium. So what exactly thermal equilibrium is? Thermal equilibrium is nothing but one of the concepts that can be explained by the zeroth law of thermodynamics. So might be all of you will learn about. Law must be first law, second law, third law. How it comes to be zero? It comes to be zeroth law because initially first law was invented, then second law of thermodynamics get invented, then lastly the basic law get invented, and at that time already we have given the first law, second law as a name. So what is the name given to that law, the basic law? That's why they have used the word zeroth law of thermodynamics, because that was invented, discovered after first and second law of thermodynamics. Now this first law of thermodynamics, zeroth law of thermodynamics gives the condition for thermal equilibrium. Thermal equilibrium means what? Let's start with one of the best example. Suppose we have taken this is beaker. This beaker contains some water. So this is nothing but a cold water, or we can say normal water we have taken. Normal water whose temperature is room temperature. Room temperature water we have taken. Now what I have done, I have taken a cube, ice cube I have taken. And when we put that ice cube in this, so this is an ice cube I have kept in a normal water. What will occur? It is seen that initially when we put ice cube, when we put ice cube in a water, the dimension of ice cube get changed. Its dimension decreases, size get decreases. At the same time, the temperature of water decreases. So what get occurred here? There is an exchange of heat. Exchange of heat. So ice is colder than the water. So this cold heat get transferred to the hot water, and due to that the temperature of water decreases. At the same time the temperature of ice get increased. So ice melt, converted into water, and temperature of water decreases. So this is nothing but what? Thermal equilibrium we have to learn. So what this, in this case what we get occurred? When we put a ice cube in a water, it is seen that ice start melting. Why it get melting? Because the temperature of water is more than the ice. The temperature of water melt the ice and convert it into water. At the same time, temperature of this normal water also tried decreasing. Why it is decreasing? Because ice we have kept. So after some time, maybe 2 hours, 4 hours, when whole ice get melted in the water, whole ice get melted in the water, at that time if you observe the temperature of this water, the temperature of water remains constant. Initially when we put ice here, so near to this ice, within this portion temperature is very much cool, and within this portion temperature is normal, as normal initially. But after, when whole ice get melted in water, temperature of every part of the water remains constant. Means what get occur? Thermal equilibrium get attained. Initially normal temperature of water is different and temperature of ice is different. After some time, 1 hour, 2 hour, whole temperature of water remains same. Means what get occur? Temperature come to be same. That is said to be thermal equilibrium is achieved. So that is meant by thermal equilibrium they have mentioned. Same thing, this can be understand when we heat a substance like this. Just same thing we can take another way. Suppose we have, instead of ice, what we have done, we have taken, suppose this is a cup of tea. Suppose this is a cup of tea. In this cup of tea we have taken hot tea, so it is hot, it is emitting some vapors in the surrounding. Hot tea we have taken here, and when we put this hot tea on a table for 10 minutes, 20 minutes, 1 hour, 2 hour, what will occur? After 2 hour, if you measure the temperature of this hot tea, it is not hot now. Its temperature is equal to temperature of surrounding. What does it means? Initially it is hot, so it will emit a heat to the surrounding, and surrounding absorb that heat. After some time, the temperature of this hot tea is similar to temperature of room temperature or environmental temperature. Means what get occurred? Thermal equilibrium get attained. And same, this thermal equilibrium was explained by zeroth law of thermodynamics. So don't waste our time, let's go to the next one. So we can say in short, when two objects are at the same temperature, they are said to be in thermal equilibrium. When two objects are at the same temperature after some time, then that two objects are said to be in thermal equilibrium. And same thing was explained by zeroth law of thermodynamics. So let's start with the zeroth law of thermodynamics. So what exactly zeroth law of thermodynamics that we have to see? So zeroth law of thermodynamics. So zeroth law of thermodynamics says that as this zeroth law of thermodynamics gives the existence of temperature difference. So there must be temperature is the parameter, physical parameter. By measuring the temperature, we can feel hotness or coldness of the body can be felt or observed by one physical parameter, and that physical parameter is said to be temperature. If the two bodies are in thermal equilibrium with each other, and one out of these two is thermal equilibrium with third one, then the first body is in thermal equilibrium with the third. So all we can say, all these three bodies are in thermal equilibrium, and that is nothing but a zeroth law of thermodynamics. So in your book they have taken three just such type of diagram they have drawn. So this is A they have taken, this is B they have taken, this is C they have taken. Such type of diagram they have drawn. So I will draw the diagram first. So A, B, C. So all these are three different bodies we can say, and finally here again they have drawn A, B and C. All these are nothing but what? The three bodies they have shown: A body, B body and C body. Now how they have explained this thermal equilibrium by this three body, that is a point to consider in this case. So let's see, the first diagram they have shown the line between A and C like this. Such a line they have shown between A and C. Second diagram they have shown such a line between A and B. And finally third they have shown line between B and C. Now see, this line represents what? The two bodies are in thermal equilibrium. Suppose the body A is in thermal equilibrium with the C. In this case, body A is in thermal equilibrium with the C. That was represented by this arrow, double arrow. So they are in thermal equilibrium means what? Temperature of A and C is same. So this A and C are in thermal equilibrium. At the same time, if three bodies we have, out of this three A, B, C, A and C are in thermal equilibrium. And second case, if A and B in thermal equilibrium, see, initially A and C thermal equilibrium, A and B thermal equilibrium, then B and C must be in thermal equilibrium, and that they have shown here. B and C must be in thermal equilibrium, and this is nothing but what? In short, we can say all these three bodies now, A, B and C, have same temperature. They are said to be thermal equilibrium, and that is nothing but what? Zeroth law of thermodynamics. If any two bodies are in thermal equilibrium, and out of this the first body is in thermal equilibrium with the second one, then the second and third body must be in thermal equilibrium. That is the zeroth law of thermodynamics. So this zeroth law of thermodynamics explains the existence of temperature, and if the temperature of all three bodies are same, then we can say all that three bodies are in thermal equilibrium with each other. Now here there is one branch of physics which deals with the measurement of temperature, that is said to be thermometry. Might be all of you are well known about thermometer. Thermometer is an instrument to measure the temperature of the body. So what we will do, that suppose this is any body, suppose this is body, and I want to measure the temperature of this body, we have to put a thermometer in contact with this. So such type of thermometer we have to put it here, and as when we make contact between thermometer with this body, when we make contact between thermometer with this body, put a thermometer in contact with the body, the temperature given by, shown by this thermometer would be the temperature of the body after reaching the thermal equilibrium. So for example, let's start with one of the best example for this. Suppose we have taken a beaker. In this beaker we have taken a water, and this is nothing but not normal water. We have taken a hot water. Hot water we have taken, and when we put thermometer in this, when we put a thermometer in a hot water, what will occur? As suppose temperature of water is 100 degrees Celsius, so it is boiling water, hot boiling water. Its temperature is 100 degrees Celsius. So when we put a thermometer in this, it is seen that when we put thermometer in such a body, it is seen that the mercury in thermometer start rising. It start rising, and quickly if you remove, the thermometer cannot show the temperature of water. Why? Because thermal equilibrium is not reached. So when we put this thermometer in this water, up to the instant that when we put the mercury rises in thermometer, at some instant mercury start rising now. Now when mercury start rising, when we put the mercury thermometer in water, it is seen that mercury start rising. When mercury rises to maximum value, mercury rises to its maximum value, now further is not going up, then we can say the thermometer is in thermal equilibrium with the hot liquid. Now you can measure this value because it is not rising now. So whatever be shown here, suppose it is 100, that would be the temperature of water. Okay, so when thermometer is in contact with a hot or cold body, when both of them are in thermal equilibrium, then the reading taken by the thermometer, taken from the thermometer, is the actual temperature of that body. So that is nothing but a application of this the zeroth law of thermodynamics. The same thing they have mentioned here. Let's go further. What is meant by heat, internal energy, and work? Let's go next topic of the syllabus. Heat, internal energy, that we have to learn how they are related. So let's start with the heat, internal energy, and the work. So let's start with heat, internal energy and work. That work we will see later on. First of all, let's start with heat and internal energy. So heat is nothing but one of the type of energy that already we have learned. Heat is one of the type of energy that can be measured in terms of temperature difference. That is nothing but heat. So here heat can be measured in terms of temperature difference. So that is the heat. And apart from that, internal energy means what? That we have to see. I hope you got heat. Heat means what? The heat is one of the type of energy that can be measured in terms of temperature, that is said to be heat. Internal energy means what? If you remember, we have seen one chapter in last bit, kinetic theory of gases and radiation. Here just start with the definition of internal energy directly. So see, internal energy is defined as they have mentioned, internal energy is defined as energy associated with a random disorder motion of molecules of a system. The internal energy of an is defined as energy associated with a random disordered motion of molecule of system. So if you remember, if we assume that suppose we have taken some beaker, and in that case, in that beaker we have taken some, suppose water we have taken, this is a beaker, in this beaker we have taken some water. So this is a water in a beaker. This water we have taken in a beaker. Now here these water molecules are at rest. Macroscopic, if you see, they are at rest. They are not moving. If they are not moving, they don't have velocity, then what is kinetic energy of the molecule? Kinetic energy would be zero. And they are at rest. We have kept this beaker on the table. So the potential energy is also zero. So practically total energy must be zero. But if you see in detail, microscopically if we see, we know that in the water molecule, molecules are seen to be at rest. But at a microscopic level, all the molecules are moving internally. All molecules are moving internally, or we can say in an atom, electrons are moving around the nucleus. So in short, all the molecules are here, atoms, electrons, they are moving. If they are moving, they don't have kinetic energy zero. If they don't have kinetic energy zero, they must have some energy, and that energy due to the random motion of molecule or atom, and that energy is said to be internal energy, because of random motion of molecule inside the liquid according to kinetic theory of gases. So this is nothing but what? Internal energy. So if we consider monoatomic gas molecule just like argon, diatomic gas molecule just like a diatomic gas molecule, we have seen it has a translational kinetic energy, vibrational kinetic energy. Apart from this translational kinetic, vibrational kinetic energy, it has rotational kinetic energy. And monoatomic gas molecule just like argon, it has only translational degree of freedoms. So that already we have learned this part. So this internal energy of system was represented by the letter U. U represent the internal energy of the system. Now let's go to understand the basic system. What is thermodynamic system and thermodynamic process? Then we will see work later on in thermodynamics, first law of thermodynamics. So up till now we have seen the heat and internal energy. Now we have to see thermodynamic system and thermodynamic process. So let's start with the thermodynamic system and thermodynamic process. So thermodynamic process. So what exactly process and systems, what these are, that we have to learn. So for that, here basically it is very essential to learn about system, thermodynamic system, thermodynamic process, boundary, and apart from this, surrounding is there, that is said to be environment. So in your book, such type of any irregular shape diagram they have drawn, and they told this as a system. So if you consider the system means what? Particle or number of particles considered for observation or for experiment, that is nothing but a system. Apart from system, anything other than the system is said to be environment or surrounding. So this anything from other than this, it is nothing but what? Surrounding. Surrounding it is said to be, or it is environment. So environment. So it is nothing but what? System means what? Number of particles, single particle or group of particle kept for a studying some phenomenon is assumed as a system. And other than this group of particles, all other things are said to be surrounding or environment. And here, this is the process. The thermodynamic system consists of the particles or group of particles they are considered for a study of some experiment, that is said to be thermodynamic system. And other than this thermodynamic system, remaining thing is said to be surrounding, or it is said to be environment of this. Now let's start with this. Thermodynamic system can be classified on the basis of how the heat get transferred to the surrounding. So there are three types of thermodynamic system they have mentioned here. The first type of thermodynamic system, as they have mentioned, is said to be open system, open thermodynamic system or open system. The second one is said to be closed system, closed system, and third one is said to be isolated system, isolated system. So what exactly these systems are? So there are three type of thermodynamic system, either open system, closed system, or isolated system. So start with the first one, open system. Open system means what? When we heat any system, suppose we have taken a system, we start heating it. When we heat it, if there is an exchange of heat as well as matter with the environment, some heat get emitted to the environment or absorbed from the environment. At the same time, some matter get emitted to environment, then that type of system is said to be open thermodynamic system, in which heat as well as heat in the system, in which heat as well as here heat energy as well as matter is transferred to the surrounding from the system. That system is said to be open system. Closed system is a system where there is only transfer of heat but matter cannot get transferred to the surrounding. Closed system is a system which is closed, under control. Something is controlled. Something means what? Heat can be transferred to the system or system to surrounding, but matter cannot get transferred. That system is said to be closed system. And third one is said to be isolated system. As its name says that it is isolated, means what? Just is under a closed environment, we can't change. Matter as well as heat cannot go to surrounding or cannot absorb from the surrounding, then that type of system is said to be isolated. We have isolate. Isolate means we have separated. Separated in terms of what? Heat cannot go to surrounding from the system, heat cannot go outside, or outside heat cannot come inside. That is isolated. Purely isolated, restricted system. Temperature or heat cannot go outside, outside heat cannot come inside. If temperature can't go, matter also can't go. So temperature or matter can't go inside or outside of the system. The system is said to be strictly isolated system. So these are the three examples they have taken here. So the first open system they have taken. So beaker we have kept and we have just put some water and we are just giving some flame to this, heating a water in a beaker. It is seen that after some time vapors are moving in the surrounding. Vapors are moving in the surrounding. At the same time, heat transfer from burner to this. That is nothing but a open system. That means heat as well as matter can be exchanged. Second example of closed system they have taken as a boiler. Boiler can be used to heat a water, but in that case the water is closed container. In the closed container water is there and we are going to heat it. So heat can be transferred from this burner to this system. Heat can be transferred, but from this the vapors can't come in atmosphere. So that is nothing but a closed system. We have closed it here. So it is said to be closed system. And isolated system, one of the best example for this is thermos. Thermos, when once we have poured hot water or hot tea or hot coffee in that, it remains hot for some time because heat cannot go in the environment, or environment cooling or hot can't go inside. So that is said to be totally isolated system. Same thing they have mentioned in your book. There is a figure 4.3b, open system, closed system and isolated system. In open system, heat and matter can be transferred to surrounding. in closed system, heat can be transferred, matter can be transferred, and in isolated system, nothing can be goes to surrounding. It remains under control position. So these are nothing but what different thermodynamic processes, and how the thermodynamic processes and how the environment and systems are, that we have learned in short. Now let's go to heat. What exactly heat? So we have started with the heading heat. In short, we have seen initially heat is one of the type of energy. Now let's see how the heat get transferred, or what exactly heat can be excluded to surrounding or absorbed from the surrounding, that we have to learn. So heat. So here heat is nothing but what, as we have learned, there are two processes, or there are two things. One is said to be system. So this is system, and another is said to be environment, or it is said to be surrounding. So it is surrounding. So these are the basic part of the thermodynamic system, thermodynamic processes, system and surrounding. Let us suppose we have the thermodynamic system has a temperature Ts. Ts is the temperature of thermodynamic system, and Te is the temperature of environment. So Ts is a temperature of thermodynamic system, Te is a temperature of environment. In this situation, we have to learn about this, how the energy or heat get transferred internally or externally, or when suppose body is heated, or cold body is kept in a hot surrounding, cold body kept in a hot surrounding, it will lose the heat. Opposite, hot body kept in cooler surrounding, also it will lose the heat. Apart from that, some of them get lose the heat to surrounding, at the same time some of the body absorb the heat from the surrounding. So there is a loss of heat as well as absorption of heat by the body, and that we have to learn under this. So here Ts and Te we have assumed as a temperature of system and temperature of surrounding. Now here change in temperature is caused by transfer of internal energy. Change in temperature get occurred, and that can be occurred in terms of internal energy. Now the first diagram, just before going to first diagram, they have to point, remember this, that point is very important. So what you have to remember, the first one, when energy is transferred to the system from the environment, from its environment, it is positive. When the energy is transferred to the system from its environment, it is said to be positive. We can say system gains the energy. Suppose this environment transfer the energy to system, so we can say system gain the energy, or it is said to be positive. Exactly opposite, when system gives the energy to the environment, we can say system loses the energy, it is said to be negative. So same thing they try to explain here. So let's start with the environment having a temperature Te, system having a temperature Ts, and here suppose some Q amount of heat is supplied, that is greater than 0. Q amount of heat is supplied, that is greater than 0, such that initially this Ts, temperature of system, is less than temperature of environment. This is the condition. The system is at lower temperature than the environment. Then what will occur? This system absorb the heat from the surrounding, and that amount of heat absorbed is always greater than 0. Q amount of heat absorbed always greater than 0, so that after some time what we reach, the temperature Ts also get increases, and that may be equal to Te, and we can say system gains the energy. System gains the energy. Opposite to this, suppose initially the system is temperature greater than the environment. It is hot body. Initially it is cold. Now it is hot body kept in cooler surrounding. Temperature of system is greater than temperature of environment. Heat cannot get absorbed. Heat get released. Heat get released from the surrounding. Now this Q is less than 0, and we can say system loses the energy, loses the heat energy, we can say. Apart from this, third one, when Ts is equal to Te, there is no emission of any heat or no absorption of heat. That is said to be system and environment are in thermal equilibrium, because both of them have the same temperature. Same thing they have mentioned, the heat, how the heat can be transferred from system to environment or environment to system, or there is no transfer of heat when there is a thermal equilibrium is achieved. Let's go to next, change in internal energy of system. So how the internal energy of system get changed, that we have to learn. I think that we will see in next video. Up till now it's sufficient to know. So just do one thing. This is a basic part we have learned up till now. Basic part, basic parameters of this thermodynamic system and chapter. So these are the basic definition. We have not started with the different phenomenon in detail. This is just introductory part. So just revise it. Just try to read it once. So watch my video and just try to read the same topic from the book and try to understand it, and once you get it, then we'll go further. Okay, so in next part we start change in internal energy of system. Okay, thank you.